Hi girls, this video contains worked solutions to the differential calculus booklet that we're doing in class. Now this first page is asking you to look at two expressions, so the function of x and then f dash of x, so the derivative, a number of times to try and work out if you can find a pattern that we can use to differentiate. So on this page, we're looking at differentiating using the basic rules, including what's called the power rule. Starting off with, how do we differentiate a constant? So a constant being just a number with no variable. Let's say we've got f of x equals 4, f dash of x equals to 0, f of x equals 6, f dash of x equals to 0 as well. The reason is that if we have a line y equals to 4, it's a straight line. It's a horizontal line and the gradient equals to 0. So for any constant, when we differentiate, we get 0. The first derivative is 0. Okay, so moving on to what's called the power rule, which is this one here. F of x equals x to the power of 2. When we differentiate, we take our power, we bring the power down in front of x. So that squared becomes the number 2. And we decrease the power by 1. 2 minus 1 is 1. So f dash x equals 2x. If f of x equals 4, equals x to the power of 4, f dash of x, we bring the power down and decrease the power by 1. 4 comes down, x decreases the power by 1. If f of x equals x to the minus 3, just be careful with your counting here. We bring the power down, so bring the whole power down, negative 3x. Now we're going to decrease the power. Negative 3 minus 1 is negative 4. And all of this is called the power rule. F of x equals 2x to the power of 4. F dash x, we bring the power down. 4 times 2 is 8, x cubed. Okay, so let's go back and have a look at this question here. If f of x equals 3x to the power of 4 plus 2x cubed minus 5x squared plus 7x plus 6. So 3x to the power of 4. Bring the power of 4 down. 3 4s are 12. Decrease the power by 1. Gives you 3. 3 2s are 6. Decrease the power. Gives you 2. 2 5s are 10. Decrease the power gives you just a plain x. And 7x, we get 7. Okay, let's do these examples. So f dash x is going to equal to 5 3s are 15, x squared, plus 12x minus 3. Now this one's a little bit different because we need to remember our indice laws when we've got an x and an x cubed on the bottom of a fraction. So x to the power of negative 1 and x to the power of negative 3. Always put things in index form. So f dash of x equals 7x, so that becomes 7. -1 times -4, which is 4x to the -2. -3 times 3, which is -9x to the -4. And I can, if I want, write it back in index form. So stop here and work on 15A, question 1. So a few more examples here on this page. They look more complicated, but they take just a little bit of algebra to sort them out. We're going to divide this fraction up into denominators of x. So 3x to the power of 4 over x plus x squared over x. And then cancel off some x's and we get 3x cubed plus x. So now we can differentiate, bring the power down. 3 times 3 is 9, and decrease the power by 1. And the differentiated version of an x is just a 1. Okay, in this one we need to expand out the brackets first. So then we can use our power rule. F dash x equals 18x minus 30, because the 25 has a constant value. And lastly, same thing, splitting up my fraction, and I can only do that because I've got just one term on the bottom. But it's a useful skill to have. Now, f dash of x. So I'm going to bring my first term down, -2x decrease, -2. -2 times -5 is going to give us a positive 10x to the -3. We're finished. So one more question here. We've got f of x equals 3 over 8x to the 4. It's much easier if we bring the x into the indices out of the fraction. And now we can do f dash of x equals, bring the indice down, -4 times 3 over 8 times by x, decrease the power. And now we're just going to simplify things out. -3 over 2x to the -5. And you could write that like this, but you don't need to. Okay, so let's do two new questions. We've got the function of x equals 3 root x plus 2 over x. The differentiation rules are exactly the same. The difficulty is the indices. So we've written them out, 3x to the half. Now we're going to differentiate by bringing down the power, 3 times a half, decreasing the power by 1, minus a half. Bring down the power, 2 lots of -1, decrease the power, -2. So we end up with 3 over 2 times square root of x minus 2 over x squared. Okay, now the next one. We've got x squared minus 4 over root x. Now we know that root x is to the power of -1/2. So let's write it like that. Now g dash x equals 2x plus 4 lots of a half, which is 2x to the -3 on 2. That's -1/2 minus 1. So that's 2x to the 3 on 2. And we're going to leave it like that. So questions in 15A, question 3 and 4 will help you practice these couple of skills here. Okay, so a question. Find the derivative of y equals x squared minus 4 over x. Hence find the gradient of the tangent to the function at the point where x equals 2. Okay, so dy dx, the same as f dash x, is 2x plus 4x to the negative 2. We've just done that by bringing down the powers, decreasing the powers. Now at x equals 2, we need to know what happens at dy dx. So we substitute x equals 2 into that equation. And we end up with 5. And that tells us that the gradient of the tangent at the point where x equals 2 is 5. Okay, we're going to find the gradient of the tangent to this curve, and this needs us to split up our fraction. So we've got x squared over x squared minus 4x to the negative 2, which is going to give us 1 minus 4x to the negative 2. So now we can differentiate this, which gives us 8x to the negative 3. X is 4 at the point. So dy dx equals 8 times 4 to the negative 3. 4 cubed, but on the bottom of the fraction. 8 over 4 cubed, which equals 1 over 8. Use your calculator if you need to check. So the gradient of the tangent is 1 over 8, quite a shallow gradient. All right, a little bit of a different question. We need to find f dash x, so that equals 2x plus b plus 1. And we're looking for the constants b and c, but we're going to need to use the information that we've got about 2 and 4. So let's do the function of negative 1 equals 2. So we're going to substitute negative 1 into our derivative. 2 lots of negative 1 plus b plus 1 equals 2. And come up with a value for b, which is 3. Now we're going to look at the function of 2 equals 4. And use that in the main equation, because that's the main function. And some algebra to tidy up. We're going to end up with 8 plus 2c equals 0. 2c equals negative 8c equals negative 4. So we have found that b equals 3, c equals negative 4.